In this video, we're going to take a look at dividing rational expressions. So, when we're dividing rational expressions, we have if p divided by q and r divided by t are rational expressions, then p divided by q divided by r divided by t is equal to p divided by q times t divided by r, and then we can write it as one fraction, or equal to p times t divided by q times r, where q, t, and r are not equal to 0. And it says, in other words, to divide rational expressions, invert the divisor and multiply. So here, r divided by t is our divisor, and then we inverted it and we multiplied. So we have times t divided by r. So in this first problem, we have a mixed fraction, so we need to first take care of that, and we can say that 3 divided by 16 divided by, now in order to get rid of the mixed fraction, we take the denominator times the number out front, so 4 times 8 is 32, plus 1, and that number goes in the numerator, so we have 33 divided by 4. Keep the same denominator. And now we want to invert the divisor, so we're going to rewrite this as 3 over 16 times 4 divided by 33. And now we want to write this as one fraction. And while we write it as one fraction, we're going to break the denominators up into factors. So we have 3 times 4 in the numerator, and then we have 16, which can be written as 4 times 4, and we have 33, which can be written as 3 times 11. And now we can see that we have a factor of 3 and a factor of 4 that can be canceled. So in the numerator, if the 3 and the 4 cancel with a factor in the denominator, we're left with 1. And in the denominator, we're left with a 4 times 11, or 44. In example B, we have a times c cubed divided by a times b all squared divided by a cubed b. And remember, we can rewrite a cubed b over 1 if we want to write it as a fraction. So now we want to invert the divisor. So we have a c cubed divided by, and I'm going to write a b squared as a squared b squared times 1 over a cubed b. So now we want to write this all as one fraction and combine our like factors. So in the numerator, we don't have any like factors, so we have a c cubed divided by, and in the denominator, we have an a squared and an a cubed, and when we multiply, we add the exponents, so we have a to the 5th, and we have b squared and b, so we have b cubed. And now, the only factors that we can simplify are the a's, so we have a to the 5th in the denominator and a in the numerator, so we have a to the 1st divided by a to the 5th, which would leave us with a to the negative 4th in the numerator, or a to the 4th in the denominator. And then we have a c cubed left in the numerator, and then the b cubed in the denominator. In this next example, we have x squared plus x minus 6 divided by 5x divided by 5x minus 10 over x plus 3. So the first thing we're going to do is invert the divisor. So I have x squared plus x minus 6 divided by 5x, and now it's multiplied by, because we're inverting the divisor, x plus 3 divided by 5x minus 10. And now I'm going to want to write this as one fraction and also write everything in factors. So I can write x squared plus x minus 6 as x plus 3 times x minus 2, and then we have another factor of x plus 3 divided by 5 times x times, now we can rewrite 5x minus 10 as 5 times x minus 2. And now you can see that we have a factor of x minus 2 in the numerator and the denominator, and those will cancel. And we're left with x plus 3 squared in the numerator divided by, we have 5x times 5 left in the denominator, or 25x. In this last example, we have x minus 3 squared divided by x squared plus 4x minus 21, all divided by x plus 7. So we're going to have x minus 3 squared over 1 times x plus 7 divided by x squared plus 4x minus 21. And now we'll write it as one fraction and write everything in factors. So we have 2 factors of x minus 3 and a factor of x plus 7 in the numerator divided by, now we can rewrite x squared plus 4x minus 21 as x minus 3 and x plus 7. So now we have a factor of x minus 3 and x plus 7 in the numerator and the denominator that will cancel, and that leaves us with one factor of x minus 3 in the numerator. And that's our video on dividing rational expressions.